Look up at the night sky. Each star you see is a sun, a distant fire warming its own family of worlds. For millennia we have gazed up and wondered, are we alone? Today that question has become urgent and practical. Our world faces mounting pressures. We have begun searching not just for neighbors but for a new home, Planet B. This is not science fiction, it is serious science. The quest to find another Earth proves our drive to explore, to survive, and to carry the spark of life beyond our cradle. It is a cosmic insurance policy written in astrophysics and in rocket science. The universe is vast. Billions of galaxies fill the cosmos. Each galaxy holds billions of stars. Those numbers suggest Earth-like planets might not be rare. Astronomers use powerful telescopes to detect the faintest wobble of a star and the slightest dimming of starlight. They have confirmed thousands of exoplanets. The census grows every day. We are sifting data for that one special place, a future. What makes Earth so special? It is all about the Goldilocks conditions. Our planet orbits the sun at just the right distance, not too hot, not too cold, allowing liquid water to flow freely on its surface, a protective atmosphere, a magnetic field that deflects damaging cosmic rays, a stable rotation, a moderate size that holds onto its air, a rich chemical broth from which life could emerge. Everything works together to create a paradise, the benchmark for all other worlds. Now, hypothetical candidate Terra 9, discovered by the fictional Kepler 9000. It orbits a sun-like star named Helios Prime about 50 light-years away. Terra 9 is similar in size and mass, about 10% larger, suggesting a solid, rocky surface and enough gravity to hold a significant atmosphere. Most importantly, it sits squarely in the habitable zone. The starlight is almost Earth-like, hinting at similar temperatures. Spectroscopy suggests water vapor in its atmosphere. The similarities are tantalizing. Its year is 385 Earth days. It may even have a large moon, stabilizing its tilt, predictable seasons, stable climate. But we must be cautious. Earth-like does not mean Earth-identical. What is the atmospheric composition? Does it have a protective magnetic field? Is the surface bombarded by lethal radiation? From 50 light-years away, we cannot yet know. A beautiful and compelling mystery, a cosmic reflection of our home, beckoning us to uncover its secrets. So, could we go there? Could humans pack their bags and set off for Terra 9? The simple answer is not with any technology we currently possess. The distances are almost beyond comprehension. Terra 9 is 50 light-years away, about 9.5 trillion kilometers per light-year, nearly 6 trillion miles. Even our fastest probe would take over 80,000 years to get there. We would need a revolution in propulsion technology. Chemical rockets are not enough. Fusion, matter-antimatter, warp drives. For now, theory and fiction, but the kind of thinking required. Even with speed, the journey would be fraught with peril. At near light speed, a tiny pebble becomes a bomb. Interstellar radiation would shred DNA and fry electronics. We would need massive shielding or powerful magnetic fields. Long-term zero gravity causes muscle atrophy and bone loss, critical on a multi-generational voyage. A 1,000-year trip implies a generation ship, a miniature Earth in space. The original crew would never see the destination. Profound psychological, social, ethical questions follow. How do you keep a stable society in a metal box? What right do we have to bind future generations? For now, Terra 9 remains a dream for a distant future. When we talk about humanity's next step, our eyes inevitably turn to our celestial neighbor, Mars. The red planet is the most practical target, 6 to 9 months away with current technology. We have explored its surface, geology, atmosphere. We know what we are getting into. A thin, unbreathable atmosphere, freezing temperatures, intense radiation, immense challenges, but engineering problems we can begin to solve. Proximity allows frequent missions and minute-scale communications. We can build underground habitats and use local water ice. Mars days are just under 25 hours. Colonizing Mars is monumental, but a concrete, achievable goal for this century. Our next logical step. Terra 9 is not a stepping stone, it is the ultimate destination. Its promise is a true second Earth. Walk under a blue sky and breathe without a helmet, a self-sustaining biosphere. A new, independent branch of civilization, free from our star's immediate fate. However, the distance demands technologies far beyond our capabilities. The investment in resources, time, and lives would be astronomical. Mars is a fixer-upper in our backyard. Terra 9 is a paradise we cannot reach. Do we pursue the difficult but achievable, or the perfect but impossible? It is the classic dilemma, the attainable challenge now or the transcendent prize far away. So, where should we go, Mars or Terra 9? The answer depends entirely on our time frame and our goals. If we aim to be multiplanetary within the next century, to create an off-world outpost, a backup for humanity, Mars is the only logical choice. It is there, it is reachable. Its problems are engineering and logistics. We can design shielded homes, extract water from ice, and make oxygen from carbon dioxide. Mars is a tangible project for our generation and the next, an investment in our immediate future. It would drive advances in robotics, life support, sustainable living, with profound benefits back on Earth. A scientific outpost to study a world that lost habitability, teaching us about our own future. It would inspire millions and secure a foothold beyond Earth, not all our eggs in one cosmic basket. Terra 9 is a choice for the distant future, not this century, perhaps not the next, 1,000-year plan. Its promise, true habitability. On Mars, we live inside machines. On Terra 9, we might live freely, in sync with a new nature. Ultimately, Mars versus Terra 9 may be a false choice, sequential stages of one grand endeavor. We must learn to walk before we can run. Mars is the school, Terra 9 is the graduation. In the grand cosmic theater, humanity is just beginning to find its voice. The choice between the dusty red plains of Mars, Ineskindings, and the distant blue-green promise of Terra 9 indeed is a defining question of our time. It forces us to confront our limitations and our ambitions and our ultimate destiny as a species. After weighing the evidence, the conclusion is clear. Mars is our present, Saurians, and Terra 9 is our future. They are linked chapters in the unfolding story of exploration. For now, Mars is the only viable answer. The journey is the hardest thing we have ever done, but within our science and will. A permanent self-sustaining presence on Mars would be a triumph of ingenuity and a critical backup for civilization. We must focus our resources and our collective genius on this achievable goal. We must learn to live on another world, even a harsh one, before we can dream of interstellar travel. Terra 9 and worlds like it must remain our guiding star, our ultimate inspiration. We must scan the heavens and build better telescopes, invest in fundamental research, propulsion and life support breakthroughs. Terra 9 is the hope of a boundless future. The path is clear. We go to Mars. That's it. And thank you for watching.